Alright, we're using the given substitution again. So put u equal to 2 plus x. Oops, just dropped the pen. Okay, here we go. So for a, we're doing u equals 2 plus x. Just in case we need it, x would then equal u minus 2 and u would equal dx. So just practice doing that. Alright, so our limits are going to change because they're x limits. We want to make them u limits. So when I sub in x equals 0, I get u equals 2. When I sub in x equals 1, I get u equals 3. Alright, so I'm going from 2 to 3. I've got 2 minus x on top. So I'm saying 2x is u minus 2. So 2 take away that. So I'm going to get 2 minus u plus 2. Dx is just du. And on the bottom, I'm going to get 2 plus x cubed, so u cubed. So I end up with 2 to 3. I've got a 4 minus u on top on a u cubed at the bottom. If we break that into two integrals, I've got 4 on u cubed, so u to the minus 3 du. And a minus 2 to 3. This would be u on u cubed, which is 1 on u squared, which is u to the minus 2 du. Okay, so this is a minus 3. So if I add 1 to the power, I get minus 2. So I've got u to the minus 2 divided by minus 2, and there's a 4 out the front. And then for this one, minus, if I add 1 to the power, I get negative 1 divided by negative 1. There we go. So 4 divided by minus 2 is minus 2. And what what am I putting in? I'm putting in 1 on 3. 3 is u. So 1 on 3 squared, so 1 on 9, minus 1 on 2 squared, so 1 on 4. And this is a minus minus, becomes a plus. So here I'm putting in 1 on 3 minus 1 on 2. All right, so we can just put that all together in the calculator and we'll get 1 on 9. Okay, let's have a look at B. So for B, we've got u equals square root of 4 minus x. Okay. So if that is the case, let's just square it to make it easier. And we can see that x will end up being 4 minus u squared. That may help us. So implicitly differentiating, we have 2u du equals minus dx. Again, our limits are going to change because they were x limits. So if we sub in 0 for x and find u would be 2, sub in 4 for x and we find that u equals 0. Okay, so the x there is 4 minus u squared, so let's put that in. 4 minus u squared is x, and then square root of 4 minus x. So the square root of 4 minus x is just u. And then dx. So dx, you can see, would end up being minus 2u du. So let's put the minus 2 out the front, minus 2. Let's u du, so let's, I'll put it separately, u du. So I end up with a u squared times 4 minus u squared. So now I can get rid of that minus by swapping the limits just to make it look prettier, and I'm timesing everything by u squared in that bracket. And if I integrate that now, I get u cubed on 3, and there's a 4 there, minus u5 on 5 between 0 and 2. So 2 cubed is actually, let's put it in powers of 2, that'll be nice and easy. So 4 is 2 squared, and then I've got 2 cubed. So if I change that 4 to 2 squared, you can see now I'm subbing in 2. So 2 cubed means 2 to the 5. So I've got 2 to the 5 on 3 minus 2 to the 5 on 5. And then I'm subbing 0 in, so I'll just get minus 0. All right, so yes, So everything has 2 to the 5 in it. That's nice. Times 2 out the front will be 2 to the 6. So I'm going to get 2 to the 6 and then a third minus a fifth. And we can see that's 5 minus 3 on 15. So that's 2 on 15. All right, so we've got 2 to the 6. You can, of course, do this in your calculator as well. But we get 2 on 15. So you see we get 2 to the 7 on 15. 2 to the 7 on 15. And if we'll probably need our calculator for that one. 128 on 15. There we go. Okay, let's look at then C. All right. So for this one, we want u to be square root of x, or u squared equals x would be the same thing. That would give us 2u du equals dx. All right, so again, let's change those limits. So let me just rub that out. All right, so changing those limits from 0 to 4, we'd end up with 0 to 2 because we're square rooting. The 5 plus square root x would be 5 plus u on the bottom. And then the dx we've got is 2u du, so I'll put the 2 there, u du. All right, 2u du. Okay, so for one like that, we know we want to make the top look like the bottom, so let's add a 5 in, and then let's minus a 5. So I'll do it separately. So 2, I'm going to minus a 5. Did I say? Yes, minus a 5. This should be a du. Was that a du? That's a du. All right. So here, the first integral would just be 1. So that's going to end up being u. So to u, what is it between, 0 and 2? It's definite integral. And this, I'm going to put the 5 out the front, so it's going to be minus 10. Isn't it? Yep, it's going to be minus 10. And then I'll just have 1 on 5 plus u, which we know is log, which is a log 5 plus u. And again, I'm doing that between 0 and 2. So if I look at the first one, I've got 2 minus 0 is 2, so that gives me a 4. Second one will give me log, it's going to be a log 7 and a log 5. So it's going to be log, oops, I've already written log. It's going to be log 7 on 5. There we go. So that's our whole answer, 4 minus 10 log 7 on 5. All right, so the last one, D. So for D, we're using the same one. So we've got that here all set up for us. So let's go, I'll do a different colour so you can see. So let's go with our limits first. So we've got 4, we're square rooting is 2, and 12, we're square rooting, so we've got 2 root 3. So we're going to get 4 plus x, which is the same as 4 plus u squared on the bottom. And we've got root x, which we know is u. And we've also got dx, which is 2u du. So you can see there that these u's are going to cancel. So we've just got an inverse tan with the, and now be careful with the inverse tan. So we have a 2 out the front, and then we are going to get the inverse tan. Now the inverse tan has the 1 on a in front of it, so we have 1 on 2 in front, and I'm going to put it out here. 1 on 2, because a is 2, inverse tan of u on 2, still between 2 and 2 root 3. So now that gets rid of the front part, which is nice, so it just becomes 1. So we have inverse tan of root 3 minus inverse tan of 1. We know inverse tan of root 3, 60, so pi on 3. Inverse tan of 1, 45, so pi on 4. So 4 minus 3 is 1, so it's pi on 12. That's our solution.